Alright, hopefully not too long a video. Just thought I'd talk a little bit about the electron spin and what I understand of it, and how it's applicable to what I have been talking about even the function of magnetism and everything. It's sort of a very relevant concept. So in magnetism, my argument is this idea that the universe is polarized. So the field energy is polarized, two polarizations, at least. But yeah, two explains it all, so why go any further? And electrons and protons are essentially the reflection of that polarization. So they have an opposite polarity, and that means that they different force hits them, they react in a different way. So the idea is that this is where electrons, the blue force caught between them as they get closer, gets stronger and stronger in the sense that it gets caught and bounces back and forth. And if you push them hard enough into each other, you will force them to separate. And in that separation, they may spin away from each other, which releases that clump of force. And that clump of force is essentially what turns out to be photons. It's polarization, all polarized, and depending on how close they were at the point of their expansion, that would dictate the frequency of the photons released. So obviously the ping pong balls would be released, and those ping pong balls would leave at consistent rates based on the bounce rate of these particles. So you can sort of get the idea. If these two things bounce away opposite each other, there will be photons released in both directions. So that even fits with the experimental evidence of paired photons. And I wasn't even looking for that, and it's just another one of the things that just falls out of this theory. Again, completely unanticipated, unengineered. It's just a consequence of the circumstance. And this all came about because I realized a few weeks ago that electrons don't hold momentum, because I was using them in the model. I was trying to do the computer model, and it didn't work because there was nothing that could engineer a permanent momentum in an electron. Because what's basically happening to both electrons and protons is they're constantly being bombarded by field energy, and anytime they get out of balance, that is, they tend to start having a imbalance in their energy in one direction, that one direction sort of sticks out as far as the force is concerned, and the force knocks it off. Kind of like the idea that moons stay round, or a lot of things like that. It's not really gravity, but it's the same kind of idea that the vacuum of force, the constant bombardment by the energy is, and especially when it's sensitive to perpendicular interactions especially, it will knock off any gains made. So the idea is opposite of same force. When opposite force interacts, so when blue polarization hits a proton, red, what happens is the force goes in, it hits a red going left or right, perpendicular, and it leaves in that direction with the old polarization, and the electron gains an arrow going forward. So it essentially converts one of the ones going inside. So one going this way inside is converted to one going forward. Now the consequence of that, though, is that this balance, if this is representing that dimension, you can sort of understand that this arrow now got longer. That means it's got more going this way than it has going that way. So two things really changed in this one interaction. You lost weight on this side, you gained weight on this side, so to speak, and you gained weight going forward. And the consequence of that is likely to be some kind of direction that's not straight. That would be spin up or spin down, spin left, spin right. And it really is dependent on the perpendicular force coming in. So if you measure something with a perpendicular force left to right, you'll end up with left and right spin. If you do it up and down, you'll end up with up and down spin. And it's exactly consistent with what I understand to be this experimental phenomenon that seems so interesting, is that they think they're measuring a different thing. They think when they're measuring left and right, it's somehow different than up and down. And it's exactly the same thing. They're measuring the same phenomenon, they're just measuring it from a different angle. And yeah, that's sort of, whatever. So anyway, and then there's the truth of this is that it is a all or nothing kind of thing. It doesn't react to non-perpendicular, so everything has to end up being a perpendicular reaction. And so that's why they get the funny results when they send in a particle that's of some off spin to the magnet. If it's at some angle to the magnet, it's not going to react unless it turns it first perpendicular and then reacts to it. And so there would be a law of averages about how much the force will turn it before it can hit it. Now, how long it takes an electron to lose its momentum, that sort of can be seen in cloud chamber experiments. So the electron is emitted, what they think is an electron anyway, and they'll see it spiral and crash. And it looks like it's spiraling because it's being pulled by something, and it's not necessarily being pulled by something, it's just forces being emitted by something perpendicular to its movement and causing it to bend into it. So it's just this perpendicular argument, really, of changing the momentum. So like as an electron's moving, so what's happening is the force is constantly working on it. So if it has more forward, like say if it got hit by a substantial force and maybe it has 10 extra going forward, and it's only got 5 going this way, so it's got a big imbalance and it's going pretty fast. It'll take a little while for the field energy, but the field energy will the tendency will be to hit this side with the 10, just stuff coming in perpendicular. The odds of averages for these things coming in perpendicular is it's more likely to hit one on this side than it is to hit one on this side. So the law of averages is that it'll keep knocking off these and sending these back to being perpendicular, or back to one of the other 2 dimensions of the 3 dimensions. So you always have to kind of think of these nuclear particles in terms of weighting in the 3 dimensions. That's how they sort of exist. And there's a tendency to stay balanced because of the field energy is always going to cut off any imbalance. So again, if it gets more blue going one way, the perpendicular energy is going to likely, just over the course of impacts, kill the imbalance. So there's a certain, there's likely a mathematically discernible potential, like a maximum distance an electron could travel before it loses its momentum, its velocity, through this process. So it's just constantly going to have it changed, and the change is going to depend on which way the law of averages again are going to dictate where, when it knocks off a blue here, whether it puts it on the red or it puts it on this other blue depends on which direction extra force might be coming from. So if it's getting extra force from one side, it's going to be more likely that it's going to gain an arrow going that way and exchange it for the force going that way. So the force will come in this way, the force will leave this way, and the electron will gain an arrow this way and now create an imbalance going down. So it'll have 2 new force entities that are changed. So it ends up with some sort of, not necessarily perpendicular. Like I said, it depends on how much this thing has been, how much velocity you have given, or acceleration you have given the electron. So if you've hit the electron with a strong force and you've moved this blue arrow much further, and so there's only a little bit this way and a lot this way, it'll take quite a while to knock all that off, and it'll be in both directions. But the point is that with each element you change. So each time you knock one of those off, and so you go one lower, you knocked one of these off and you added it here, you're still maybe 5 or 6 plus here, and you're, say, 1 plus here. So you have to add those 2 vectors and say, okay, well, the movement's going to be not perfectly straight, but not not a diagonal either. It's going to be something a little less than straight. That kind of thing. So, so anyway, I think it just happens that this mechanism does provide reasoning and a model to describe why electrons don't travel straight, why they do spin up or spin down or spin left and spin right. That it's in the nature of how they react to force, in the sense that they're more than one vector is changed by the interaction. They don't just do a straight up this for that exchange, in the sense that they're also exchanging, they're moving stuff from one dimension to another dimension. So the point being is the electron always stays, it has 100 of something, and it always stays 100. And all it changes is where the 100 is located in the dimension. So which one of these arrows is heavier, is all that changes. So it's always the same weight. It's always had the same mass in directions. It's just which direction it has more mass in changes. Alright, I think that's enough for just this first video on the subject. But like I said, this is the fundamental, this is the entire universe, is this mechanism, this polarization thing, is the whole game. And again, like I said, it can explain photons, it explains electron spin, it explains magnetism, and it explains why gravity is a weak force, because gravity's draining. Gravity's having this, I've explained it, I gave this before, and Hockley did make some kind of criticism as if gravity can't be explained with this polarization, but it really can, in the sense that gravity is a mixed, both entities have a mixture of the, both, they have protons and neutrons, and so they are doing this process of creating more and more reflection, but at the same time they're doing this draining process. And it's really what's happening is the gravity first has to work its way through the material form, in the sense that it's leaking both forces through itself, and that takes time. And then there's the process where the force bouncing back and forth, a blue force hitting this, going this way, can bounce off a blue here and then bounce back and then hit a blue again and then bounce back. So it's this law of averages thing. So it takes, the force is strong, but it's not like the complete evacuation that happens in the case of when a proton is with an electron. You have a very strong attraction because all the force leaks out and there's no repulsion between them. And the opposite effect of when they're all blue, or the same polarization, and you end up with this block, this trapped force. Neither one of those scenarios are completely realized in gravity, and that's why it appears to be so weak. It's one of the reasons. The other reason is that the gravity, unlike these forces don't emanate force in different directions. I could almost draw these as squares to be even more realistic. And so their transfers are very direct, very digital, where the force being conveyed between a sun and the earth, whatever force this thing pushes in, the arrows can leave in all kinds of different directions. They'll never hit this thing again. And that's another reason why the force is weaker, is that the vacuum, in a sense, isn't necessarily, well, vacuum is the wrong word. The mechanism is, the main point is that the force is slowed down so it can't be trapped, and that's really the main mechanism. And that's why you need velocity in a direction to stop the gravity from consuming you. But the fact is that you're constantly generating acceleration in, but it's just not enough to it can be overcome by a velocity. Where these kinds of interactions, velocity is not going to, if these two things are spinning or something, there's no way velocity is going to change the relationship. So that's probably enough of that. Yeah, so like I said, it's all the forces are right here. Everything is right here. It's all right here. just recognizing that the things we call particles aren't really particles. They have 3 dimensions. The 3 dimensions themselves, the force elements, are all tons. They're all a kind of photon, and they're all trapped. Gravity, light, which would be these ones at a higher frequency, and magnetism, which is really just recognizing the 2 colors. So magnetism is really strongly dependent on polarization. Light is dependent on polarization at a frequency, at a vibration, and gravity is the field energy. So it's like the little tons only have momentum in one direction, they only have velocity in one direction, they only have mass in one direction. And the rest of the things only have mass in more dimensions if they have those dimensional elements within them. And that's what makes matter matter, is that it has energy in all 3 dimensions. And so that's why we have what appears to be substance, is because all our mass isn't going in one direction at the speed of light. It's still going the speed of light, don't get me wrong, but the pattern isn't moving the speed of light. The pattern is trapped. The exchanges are happening all the time, but the color stays. Electrons stay blue, protons stay red, and they exchange red and blue arrows constantly. Alright, so that's probably enough. Yeah, that does it. So, I'm just saying, it is quite interesting, and you know, I'm going to try, you know, anybody who knows of, like I said, a good link for, you know, not one of these animation videos of a metaphor for the experiment. I want to know how they actually do the experiment. So if somebody knows a good link that explains the exact process of preparing an electron and then sampling it, I would be interested. So thanks. Till next time. Such.